Today we're gonna have a look on this APC power distribution unit. This video is focusing today only on the hardware itself. So I'm gonna first go over what are the functionalities and what can this unit do for us. Then in the second portion of the video I'm gonna then tear it apart and we're gonna look at what are the actual components which are doing the power switching and what kind of processor is running the show. And if you are interested instead on the software part of it, so the command line interface, web interface, then that will be the topic of the upcoming video. The original owner who sold me this unit through eBay no longer remembers the password, so I need to then reset the password. But for that I will need to make this specialized APC serial cable for that. So this is why I'm shifting that part to the upcoming video. So then let's go.
Welcome to Donkey Learning IT, where we go over certifications, hardware, software and IT related jobs donkey style.
First of all, what is the main idea behind using such a power distribution switch? Well, the main idea is that you feed in here through this port your power inlet, then these 8 outlets are then going to your devices which are then consuming electricity. So these can be then switches or PCs or routers. It's entirely up to you what you are driving through these ports. And since you have now here both the serial port and especially the network port, then you have the luxury to actually be able to control what is happening with these power outlets, and this can lead both to power saving, first of all. Second thing is it can do automatization. So if this is, as an example, you wanna reset a switch, just let us make up an example. You always wanna reset a switch on once a day because you know that it has some issue. It's a cheap old switch from who knows which manufacturer. You can actually do that. Or more realistically, you can buy one of these units, then attach it to your lab, then attach it to some small low power computer, and if you're in your job or abroad, then you log into this small computer like a Raspberry Pi or Banana Pi or something like that. Then you log into this device, you turn your PC or your server or whatnot up, and then you do all your lab exercises. And once your slow time in your job is over and you have to actually do something, then you just shut everything down and you're gonna save tremendous amount of power. To give you an idea, in the place where I live, I have to pay 28 euro cent per kilowatt hour, which is a lot of money. So I would expect that I can make back just through by saving money this unit in about half a year or so. And in addition to that, of course, it's always fun to have a nice APC PDU, because then you can have the learning experience to deal with such type of equipment as well. On the right hand side of the device, now then there are all these I/O, so you can somehow communicate with the PDU. Then on the left hand side is the actual power input. So on this port then you can plug in your power cable, which is the typical power cable, so the C13. You can just plug it in there. and through this cable then you can put in a maximum of 12 amperes, and in the case of the European power that means that you can have a maximum of 12 amperes times 230 volts, which is, give or take, it's about 2.5 kilowatt of maximum power. And then for the output you have then 8 of these power output jacks. Then you have to use this C14 plug right here, and on the other end then you have the typical power plug, which you can just plug into network switches and routers and whatnot, what you want to control through this power distribution unit. On the back side now then there are these stickers. So here is then the model number, then the serial number. Then this sticker is most probably showing that this is not machine washable. I'm just joking. I think it's that you are not supposed to throw it out with your normal trash. The unit can do from 100 to 240 volt AC, both 50 Hz and 60 Hz, no problem. Both are working just fine. However, take care that it can handle a maximum total combined amperage of only 12 amps. For a home use, this is super enough for most people. I mean, if you are pushing this APC with some really tough servers which have several like GPUs, you are doing like a GPGU computing or so, you might want to look at a higher end model than this one. There is also a smaller sticker which actually gives you the MAC address of the network port which is inside the unit. So I'm referring to this network port here, which is then used for communication with the power distribution unit. So this one has already web management and all kinds of goodies built into the unit itself. So you are able to log into this unit through either through the serial port, as I already mentioned, which, as you see, it's an ARIOT 12 jack. So you need a specialized power, or not power cable, but sorry, a serial cable from APC. Actually, we're gonna build that cable because they are quite expensive, especially considering that I will need to order one from the US. So the delivery fees to Germany would be like, close to 30 euros. Anyway, the other way to communicate with the power switch is through this built-in 10100 port. The main idea is that you are connecting to this power distribution switch either through the serial port, which is like out of band management, we could consider it like that. So then you are telnetting it into the device, or you are putting this switch, power switch in this case, then you're gonna link it up with a actual network switch through this 10100 megabit port right here. And then you can either use the web interface or you can use the CLI to do your things on it. So then you can configure all these ports and you can decide what is then happening with the power. And in addition to that, there are also 3 of these LEDs in the front. And the good thing is when the OK is lit green, then if the switch is overloaded, it can maximally switch up to 12 amps combined. So it means that all these 8 ports share a maximum power of up to 12 amps of 230 volt AC. If you overload this PDU, then this will then turn red, which is no good. Then here normally you have the power usage displayed in form of amps. This is because the unit is not able to measure voltage, so it only measures amps, and then based on the volts times amps you can estimate the power. If you push this DOM switch down for a long time, then actually it will show you the current IP address set for this interface right here. And this IP address, will fly by, because as you see, it can only display 2 digits at a time. Next to these LEDs and this 7-segment LED display, there is a small hole where you can try to reset the device. So if you push with a sharp point here, then it will start the reset procedure, which means that it will temporarily reset the password to the default APC, and also the main user, the administrator user, will be also APC for 30 seconds. However, you need the cable in order to actually perform the reset. So if you don't do that, then it will just automatically power cycle and come up with the configuration in there. So this is something what you need to keep in mind if you have such a unit. Below the power outlets, notice that there are also LEDs built into the unit, and these LEDs then give you a status of what is going on with the power on these given outlets. Otherwise, there is really nothing to see on the bottom. There is absolutely nothing on the back side except a nice APC logo. And yeah, on the top side there is also absolutely nothing as well. So all the fun is then in the front side. So this is just the business side. This sums then up the quick overview of what the hardware is doing. And now it's time then to tear it down. So open her up and look inside then what is doing the power switching. And for that, actually, I will need to, of course, remove this APC warranty void sticker. I mean, this unit no longer have warranty long ago. And I don't know how much you can notice, but the unit was a little bit dinged up by the original owner. So I want to check that everything is still fine inside before I actually put it into my lab. Here then a warning: please never ever tear down any kind of electronic equipment which is then still being powered, or which can still hold enough power to cause severe damage or kill you. In order to open up the unit, we're gonna need to remove these small screws which are all over the case, as you see here. Then let us remove those screws. Here is then the unit with all the screws removed. I mean, it had a really schmick warranty void sticker. I don't know whether you can see it, but it really had, this small void word embedded in it. Even though I managed to peel it off in one piece, I mean, it still have left, these words of void, and I could obviously not put this back. So congratulations to the manufacturers to making one sticker which is actually, easily tells them that someone have opened the unit, because most of the time you can just open these and put them back on and most probably no one gonna notice. And after you removed all the screws, then you can just nicely lift this thing out and push it out. And here you go. Here is the cover. So we are already getting a sniff of what is inside this thing. Let us then check it out. So first let us then have a quicker look on what are the major components. And then, of course, let us then zoom in. By the way, regarding then this ding, because the previous owner have dropped the poor unit, then as you see, the ding is right here where there is practically nothing in the case. So I would suspect that if the drop would have happened at this side, where there is actually lots of stiffening mechanics, my suspicion is that it would have not even bent. So this is how really well built this chassis is. I like it quite a lot. It's really a well built unit, and as you see, of course, they are just repeating this whole relating. So by the way, the main switching elements are not surprisingly simple mechanical relays. Then, as you see here, this blue rather thick wire is then the neutral wire, which is then being just, commonly put through all the output plugs, so these ones. And then notice that the brown ones, so which are the hot wires going to the outputs, then the hot wires are actually being switched by these mechanical relays. And of course, the mechanical relays gonna get their signal from this board here. Here is then the power input plug, and this power input plug is then leading to two relatively thick power cables. So then this would be the hot, and the blue one would be the neutral cable. Just look at this nice shake-proof washer thingy and the earthing. I mean, this is a proper job. This is what I would expect from a really well-established manufacturer like APC. So yeah, I'm loving the power input. Also, they put these rubberized, they are plastic, but nevertheless they put these plastic boots, of course, on the individual connectors of the power input. And as you see, also on the power output connectors, so on these, they are also putting then these nice boots on. So as far as I can tell, there is no mains wire being exposed in the PCB. So after these 8 outputs, then we are coming towards the brains of the whole device. So as you see from this portion on, so on the right side, is only digital electronics, so there is no longer any power switching done. And we find that the whole show is actually run by a ASIC, most probably. I don't know whether it's an ASIC or it is a rebranded standard CPU. We have to look at the real number and try to figure out whether it's just a rebranded device. They have done also a really nice job of using this formed sheet of plastic, which is most probably then bent when it was still hot. And this plastic runs below this whole PCB, which is then carrying the 230 volt AC or the mains voltage. So it means that they really took care of having a good isolation between the PCB and the metal chassis itself. In addition to that really nice ground wire there. I mean, come on, that is just awesome right there. In addition to these plastic boots, they are also actually heat shrink tubing all these cables here. So as you see, this is the original blue cable, the neutral wire, and then here suddenly it turns into a thicker black wire. Well, that's because they nicely heat shrunk the cable itself. I mean, yeah, I'm really positively impressed by this thing. Then also notice that they are zip tying all the components which could, go loose. Again, everything is heat shrink tubed nicely. There is actually a cable, a flat cable going from one side to the other. I don't really fully understand as of yet what this is doing, but this is also nicely heat shrunk as well. And you see it is only getting exposed once it goes to this side where there is only the digital electronics working most probably at 3.3 volt DC, so there is really nothing in here going on. And even in this side you can notice that everything is zip tied down, so yeah, I mean, pretty good stuff. Regarding the construction of the printed circuit board, so practically there are two larger PCBs inside the case, and the two PCBs are split here in the middle, right where the relays are. You see this black plastic, which is practically the same black plastic like here on the back side. So then this is splitting the two PCBs, so these are then just two rather thin but quite long pieces of PCB running along the case. Here this upper PCB is the one which is then holding the transformers for the current measurement. Then here are some AC to DC switch mode power supplies. Here we can clearly notice that this PCB is a pretty standard PCB apparently for these APC power distribution units, because you can notice that there are actually three phases present on the board. So you see phase A, if I cannot really see it on this small LCD display of the camera, so I would say that this is phase A, that's phase C, and that's phase B here, which is actually being populated. Namely, this unit here is a single phase unit, as you have noticed by now. But nevertheless, the board is still a three-phase board. So my suspicion is that the engineers at APC said, yeah, for us it's not worth to respin the board for a single phase unit, because then we're just gonna populate these transformers, and at the end of the day this portion of the board with the switch mode power supplies, that will be necessary anyway, so it was most probably just cheaper for them to keep it as a three-phase board. What happens is that here, as you see, then there is this hot wire coming in, the brown one. Then this goes right here to one of these metal ears like that one, but it's of course only going to phase B because it's a single phase unit. Then it goes through this current transformer right here. I don't know how well you can see it, so there is a thicker cable which is then for the AC, and then this is then just a transformer body, so there will be a small voltage induced in this winding, and this voltage will depend on the amount of current going through the unit, so how much power you are using practically. And that means that they can then measure the current without actually tapping into it, so they are not using a drop of resistor or so, which is a lot neater solution. And then the power goes through the current transformers primary, and then it goes to this lead right here, which is then the hot lead, and this is nicely heat shrink tubed. This hot lead then just nicely goes through. It pops up right here, so it is just going along the board. and then it goes into this connector on the other board, so the board which is then separated by the power supply part by this plastic and which holds the relays. And then of course this is then probably just a parallel rail right here. As you can see, there are these connectors right there below, and then this hot rail is then being switched by the relays for the individual power output plugs. The switching relays themselves are really high quality Murata relays, so they can, as you see, they can switch a maximum of 16 amps for 250 volt AC, or a maximum 20 amps for 124.5 volt AC, and then the voltage used for the energizing the magnetic part of the relay to close the contacts, that is 24 volt DC. Since when the relay is being de-energized, then there is a huge pulse being generated, and in order to take care that this pulse is not destroying the electronics, notice these larger black diodes on the PCB. It's really hard to show because I don't have much space due to all the cables. Then regarding the two switching mode power supplies, or the other board in general, I actually removed this cable out of the way so we can see what is going on here. Since the relays are powered by plus 24 volt DC, and in strong contrast to that, the digital electronics is then powered by plus 3.3 or up to a maximum of plus 5 volt DC. This meant that they had to provide two different DC voltages going to these two different boards, so the digital electronics and the switching electronics. And what apparently they did is that they are using two different switch mode power supplies. I mean, technically speaking, they could have used even a single transformator with two secondary windings, but probably to increase the safety and to make this thing more bulletproof, they are even using two different switch mode power supplies, which I'm actually a bit surprised about, I must say. And this is because the two power supplies, of course, will increase the bill of materials, it will increase the cost, but considering how much money you have to pay for one of these units, I think they are still making a good margin on this. So yeah, I don't even really want to know how much a new APC PDU would have cost me instead of the 70 euros I paid for it used from eBay. So then what happens is that the AC is coming in. So these are the two fuses right here for the two different switch mode power supplies. Then we have two Grates rectifiers. Where is the other one actually? Oh, it's right there. I don't know whether you can see it from this camera angle. Then they are going through two of these common mode chokes, so they are pretty much using the same configuration like in the example application circuit. Here then you can see a typical way how this TOP244YN monolithic power switching regulator would do its thing, and this is really similar what they are actually implementing in this APC PDU. So here is then the line voltage coming in as AC, there is a fuse, some minimal filtering going on here, then we have the Grates rectifier bridge which goes into the bulk filtering capacitor. Then we have this resistor network for the over and under voltage protection here. Then we have the integrated circuit, of course. and this is a typical flyback configuration. So then the power field effect transistor, which is of course inside the chip itself, is then the source is just put down on the negative voltage or the negative rail. Then the drain is directly connected to the primary of the chopper transformer. Then, as you see here, this is a typical snubber circuit, so with the high voltage diode and the resistor and the high voltage ceramic capacitor. And then the secondary is then have two windings. One of the windings is for the actual output voltage, which provides the power here. Then this is just a normal Schottky diode doing the rectification. And then of course you have the filter capacitors for the outgoing voltage. And as you see, the secondary winding is then providing the feedback voltage. And this is done so, instead of, using this here as the feedback, is because we want to have a complete galvanic separation between the primary side, which is at the mains volt. So yeah, it can kill you easily if something bad happens. And with between the secondary side, which then should not carry any dangerous voltages. So this is why they are using these two different windings. And for the feedback, they are then just using the very typical optocoupler, where then the optocoupler is then being fed by a voltage reference Zener diode here. And then this provides the feedback signal for the integrated circuit itself of how much power it should feed into the primary side of the circuit. Then, of course, as I mentioned, then they are using a TOP 244YN monolithic integrated circuit, which is already ready-made exactly for these switch mode power supply applications. In fact, you don't even need to put, according to the datasheet, up to a 34 watt, if I remember correctly, power. You don't even need to put any heatsink on the circuit, so it's a pretty well-designed stuff as well. Then, just as on the datasheet, they have the transformator itself, so the chopper transformer. And this is really, really small. I mean, look, it's barely larger than my finger, but considering how little power they need, I mean, that is fine. Plus, of course, this is one of the transformators. And then here is the other one for the plus 24 volt DC. And these are the bulk capacitors right there. And that is the other one. 47 microfarad, 400 volt. And yeah, so on the other side one can see, I cannot show it to you on the camera because it doesn't focus at this distance. So they are 105 degrees, but actually they are a Lelon brand, and I must say I don't know much about this Lelon brand. Is this good? Is this not good? I have no experience with them. So I mean, if they are putting an APC unit, since they haven't saved money on the relays themselves, I mean, they are Murata, I don't see the point why they would now save a couple of cents on the capacitors themselves. So it could be that this Lelon is not a bad manufacturer. It's just, I don't know anything about them. So yeah, let me know eventually what do you think about the capacitor. Just as in the datasheet, they are using then, of course, here a optocoupler, and then yeah, this is then providing feedback for the circuit itself. And then this black thingy here is a double Schottky diode for actually making again DC out of the chopped DC here going through the transformer. And then they are using 2 filter capacitors, and the filter capacitors are also Lelon branded and for 105 degrees C. Regarding the digital electronics, as you see, there is one chip which is dominating the whole thing. So I tried to look it up. It seems that it is a Atmel produced, most probably it's some specialized microcontroller, but I could not find any datasheet for it. But as you see, they have nicely engraved the APC logo. So, I mean, APC is a big player. No wonder that Atmel just put their logo on the chip itself. And considering that there is not much available, I mean, most probably then this is then indeed made specialized for APC. Then right here in the corner, this is a 32 kilohertz crystal, because this thing have actual real-time clock. And then this is the real-time clock is derived from this crystal right here. Then this is here the flash chip, which is then holding the firmware. Below there is of course a battery for the real-time clock chip, and there is also here this static RAM chip, which is then holding the configuration as well. And there is some minimal power filtering taking place for the digital electronics. Then there is another board here which is totally boring. Actually, the main crystal for the chip is on this board right here on the back side. Otherwise the back side is nearly empty. And then they are using right here this cable to communicate with this board here, and also this cable which I removed so that we can have a look on what is going on. This front board is then connected to the I/O, so to the 10100 megabit Ethernet port, to the serial port. It has the button and the 7-segment display, the 3 LEDs which I mentioned at the beginning, and of course it also has the PHY or the physical input-output chip for the serial port, and of course the RS232 conversion chip, most probably a MUX32 for the serial. The only thing which I could eventually point out as not the best is this capacitor right here in the front. It's really a bit of how are you doing job. It's floating on there, so yeah, I mean that could have been definitely improved. This then sums up the general overview and a quick teardown of what is inside this APC power distribution unit. I hope you had fun. I know I had. And at least now we are all smarter a bit and we know what is inside one of these units. And then if you are interested in the software part and configuration and actually resetting the password, where I'm gonna make one of these specialized serial cables, then please watch part 2 of the video. And many thanks for watching.